For centuries, the Romans governed the most powerful empire in the history of the Mediterranean world. Roman armies reached the Scottish Highlands and the Persian Gulf. Roman merchants established trading stations in India and ventured to the court of the Chinese emperor. A polar bear was brought to Rome, and lead from Roman furnaces settled on the Greenland ice cap. The apogee of Roman power seems to have coincided with an era of exceptionally warm and stable weather, usually called the Roman Warm Period, or Roman Climatic Optimum. Today's video, which is sponsored by Klima, will explore the nature of that warm period and its significance for Roman history. Geologically speaking, we're now in the Quaternary period, which began about 2.6 million years ago. The vast majority of those 2.6 million years belong to the Pleistocene epoch, which was defined by a series of ice ages. The end of the last ice age, about 11,700 years ago, marked the beginning of our current epoch, the Holocene. Although the Holocene climate is, at least by Pleistocene standards, both relatively warm and relatively stable, it has always been characterized by fluctuations. Unlike the anthropogenic global warming of the past century and a half, which is driven primarily by the burning of fossil fuels, these fluctuations are natural and manifest as long-term regional anomalies in temperature and precipitation. The Roman Warm Period is usually thought to have lasted from the early 2nd century BC to the mid-2nd century AD. Our understanding of it derives from climate proxies, physical evidence correlated to changes in temperature or precipitation. Proxies take many forms, from the layered sediments of lake beds to calcite formations in caves. But a few proxies are especially important. The most precise evidence is provided by dendrochronology, the study of tree rings. In temperate climates, most trees add a ring of new wood each year, wide when growing conditions are favorable and narrow when they aren't. Using wood preserved in bogs and other saturated environments, scholars have created ring sequences dating back to the Roman era and beyond. These records reveal a long period of warm summer temperatures in the Alps and northern Europe, which peaked in the 1st century AD. Corroborating evidence comes from the Greenland ice cap, where ratios of oxygen isotopes and chloride levels in layers of ice deposited during the Roman imperial era suggest several protracted periods of warm temperatures and low sea ice in the first 2 centuries AD. Careful study of glaciers in the Swiss and Austrian Alps has revealed a long period of retreat in the same era, which may have reduced some glaciers to their late 20th century size. For at least short periods, some regions experienced exceptional warmth. Until recent decades, the cold-sensitive nettlebug was found only in southern Britain. But during the Roman era, it scurried happily throughout the north, which suggests summer temperatures at least a degree Celsius warmer than mid-20th century averages. Levels of atmospheric mercury in a Spanish bog have been interpreted as evidence that the peak of the Roman Warm Period was something like 2 degrees Celsius warmer than 20th century averages. Analysis of plankton remains in the central Mediterranean suggests local sea surface temperatures much warmer than today's. Near the Roman city of Sagalassus, high in the hills of what is now southwestern Turkey, archaeologists have discovered olive presses and olive pollen in areas far too cold for olive trees today. Like Roman olive crushing installations found in the mountains of Greece, their existence may suggest average temperatures at least 2 degrees Celsius warmer than today's. Some parts of the Roman world must have been exceptionally warm, at least for a few decades. But the degree of warming varied considerably, both over time and from region to region. Looking at the Roman world as a whole, mean temperatures at any point in the warm period were probably more or less comparable to late 20th century averages. Neither the height of the Roman warm period nor any other climatic anomaly since the end of the last ice age can match the global warmth of the past 2 decades. The scale of the modern climate crisis can make the problem seem too big for one person's choices to affect. But thanks to this video's sponsor, Klima, anyone can make a difference. Klima is an app that helps you manage your carbon footprint. After signing up, you answer a few questions about your lifestyle. Next, You choose ways to offset your carbon footprint by funding projects that reduce emissions or remove greenhouse gases from the atmosphere. The app then allows you to track the impact of the projects you support. So, if you want to make the world a greener place, follow the link in the video description and sign up for Klima. If you use the promotional code ToldenStone10, Klima will plant 10 extra trees in your name. So join me and go carbon neutral with Klima today. Unlike modern climate change, the Roman warm period was not a worldwide phenomenon. Even when the Mediterranean and Northwest Europe were warmest, other parts of the globe show no signs of unusual heat. Even around the Mediterranean, the Roman warm period does not seem to have been consistently warm, since tree rings and other proxies record decades-long interludes of cooler weather. The climate affects history in surprising ways. We know from tree rings, for example, that the period around 218 BC was exceptionally mild in the Alps, making it much easier for Hannibal to lead his elephants over the mountains. Another set of tree rings, this time from Central Asia, bears witness to the terrible drought that drove the Huns westward in the 4th century, starting the barbarian invasions that would bring the Western Roman Empire to its knees. In the case of the Roman warm period, the big question is the degree to which a warm and generally stable climatic regime contributed to the growth and power of the Roman Empire. Most Romans, after all, were farmers. If conditions were consistently favorable for agriculture over a wide area, the empire would have benefited. Yet even if sustained warmth boosted crop yields and opened new areas to settlement, as some scholars claim, the importance of the Roman warm period should not be overstated for two basic reasons. First, as we've seen, the period's warmth was neither uniform nor consistent. It did not change the basic parameters of farming and empire building in the Mediterranean world. Second, tempting though it is to correlate good weather with Roman success, history is not that simple. Although the climate mattered, its impacts were always conditioned by human institutions, human understanding, and human decisions. The Roman warm period may have helped to define the environment in which the Romans lived and strove, but it did not determine their fate. If you enjoyed this video, please consider supporting Tolden Stone on Patreon. You might also enjoy my book, Naked Statues, Fat Gladiators, and War Elephants. Thanks for watching.